Welcome to Unit 1, Lesson 5. Sequences are functions. So now we are going to start to deal with function notation. You've seen it before, but get used. Function f of n just means y. That's all it means. So where you had mx plus b before, it's the same thing. Well, you don't have x anymore. Whatever is inside your function, it must match. So this must be mn plus b. So these things must match, and that's the only difference. I could have had f of x equals mx plus b. I could have did that. All right, so function notation, f of n, that's how we say it. It just means y, your output. It's just your output. Okay, let's learn how to define a sequence recursively. So now we have our first formal sequence definition. There's another sequence we're going to learn about later. Okay, describe how to produce one step of the pattern from the previous step. So we got one dot, we got 3 dots, we got 6 dots, we get 9 dots. No, 10 dots, I'm sorry. Not 9, 10 dots. Okay. So there are all kinds of ways to looking at this. But what I want you guys to do is to notice this horizontally. If you look at it horizontally, row 1 is all the same. Row 2 is the same for 2 and above. Row 3 is the same for 3 and above. And row 4 is the same for 4 and above. So if you look carefully, each step, we're adding the step number. So is whatever the dots are, your first step, you have 1 dot. So step 1 equals 1. And then from there, you add n for whatever the step number is. Whatever the step number is. So step 1 equals 1, and then you add n, whatever the step number is. Or I could put D for dots, whatever. Okay, now it's the same pattern again. So basically what we're taking is the previous number, 1, and step 2, D of 1 is 1, plus 2 gives us 3. Step 2 is 3, so in step 3 we take D of 2, which is 3, plus 3, that gets us 6. In step 4, we're going to take D of 3, which is 6, and we're going to add 4 to it because that's our step number. And that will give us 10. Remember, a sequence is the output. And we're going to take D of 4, which is 10, and we're going to add 5 to it to get us to 15. Okay, so now this is how we write our sequence. Our function, D of n equals the previous term, n minus 1, plus the step number. So our output, D of n, for any step in a series, is the previous term plus the step number. And we're going to add a little bit more to this later, but right now, understand this. That's what you see in the pattern. The function output is the same as y, n is the input, same as x. On this page, I'm going to do 1 and 3 and 5 to give us some room. So now we are going to state if it's arithmetic, geometric, or neither. So the first thing that we do is write our change. So for 1, it's plus 10. That means it's arithmetic. For the second one, it's times 2. That means it's geometric. For the third one, it subtracts 7. That means it's arithmetic. Okay, now let's write a formal definition. I probably should have did this in different colors, but my fault. I'll put the first one in red, and then I'll change the colors for the next ones. Okay, so arithmetic. To write a sequence recursively, you need the first term. So A of 1 equals 30. Now, just like in the previous one, the output, A of n, equals the previous term plus the change. Now, the only thing you didn't see before is 4n greater than or equal to 2. If this is 1, our first term is 1, the next term must be 2. This is called the next term. Obviously, our change is our change. This is called our previous term. And this is our output, as always. And this up here, this whole thing, is your first term. Now, every time you write a formal recursive sequence, you need your first term, your output must be equal to the previous term, the change, and the next term. You need 1, 2, 3, 4, 5 things to write a recursive sequence. So let's see how to write it geometrically for term C. All right, for C, we had C of 1 equal to 1. C of any term in the sequence is C to the n minus 1 times 2 for n greater than or equal to 2. Because this is 1, this has to be the next term. And for term E, or sequence E, we got E of 1 equals 20. E of any term equals the previous term. E to the n minus 1 just means the previous term minus 7, just like in the table that we saw on the previous page, for n greater than or equal to 2. That's it. Now you know how to write a formal recursive sequence. And on this page, we're going to do 2, 4, and 6. So this is divided by 2. So this is GO. This one, 4, is times 1/2. So this is GO. And 6. Oh, this looks like the Tower of Hanoi one. Look at this. 1 times 2 plus 1. 3 times 2 plus 1. 7 times. So this is 2n plus 1. This is neither. And yeah, neither. Okay, so let's write our sequences. So A of 1 equals 80. Any term equals the previous term. Oh, this is actually B. Well, I'll keep writing A. I just got A on the brain. The previous term times the change times 1/2 for n greater than or equal to 2. The next one. D of 1 equals 1. D of any term equals D to the n minus 1 times 1/2 is the same as divided by 2. And the last one. Yes, neither sequences can get a function rule. So let's write it out. F of 1 equals 1. F of n equals 2 times the previous term, f of n minus 1, minus 1 on the outside. So that's your 2 times the previous term minus 1 for n greater than or equal to 2. Okay, looking at our synthesis. So far, what I want to highlight is we know a sequence. We know the geometric sequence. We know multiply each term by the growth factor. Here's an example. The growth factor is 3. Here's a formal recursive definition. The bottom ones we're going to worry about when we get to this. So I'm going to have to insert this slide into the next one. And we'll highlight this later. Now, when you have an arithmetic sequence, highlight these 4. So what we're concerned with today is recursive sequences. The formal recursive sequences. Arithmetic sequences have rates of change. Geometric sequences have growth factors. If you compare them, most of the stuff is similar or same, but there's minor differences when it comes to this line right here. Let's put a dot by it. This line right here, line 4 is different, and line 2 is different. Okay. Can you define arithmetic and geometric sequences recursively using function notation? Yes, you can. Take the time to practice on the practice problems and then watch the video to see if you got it right. There's a vocabulary. We've already went over that. So thank you for watching.